We're going to discuss here exponential functions. These are special functions. There's a lot you can do with these. Exponential functions. So the general representation of an exponential function, this is a very basic representation, a to the x. A is called the base, and x is called the exponent. So anytime the variable is in the exponent, we call it an exponential function. This is also the same as saying y is equal to a to the x. I'm not going to require my students to graph much of these because you could just plug them into the calculator, but there are some things I want you to realize regarding these exponential functions. There are three main points that we talk about when it comes to graphing these exponential functions. And the first one is when the x-coordinate is 0, the y-coordinate is always 1, no matter what. I mean, there's no coefficient here. If it's just a basic number to the x. Anytime the exponent is 0, anything raised to the 0 power is 1. 1, anytime the exponent is 1a to the 1, it's going to give me 1a, and then negative 1, and then 1 over a. So a to the negative 1 is 1 over a. So, if I were to just really quickly, let's say 2 to the x, really quickly graph this, I'm just going to focus on these three main points to roughly sketch this. And every exponential function follows a similar type of look. So 0, 1 is always going to be a point. A in this case is 2, so it's going to go through 1, 2, right? When x is 1, 2 to the first is 2. When x is negative 1, 2 to the negative 1 is 1/2. And you'll notice that every single exponential function in basic form looks like this. This is exponential growth because it's increasing from left to right. If a is greater than 1, we have exponential growth, right? It's going to grow fast. If a were less than 1, so let's do an example like that. So let's say 1/2 to the x. So in that case, again, this graph is going to go through 0, 1 also. When x is 1, y is 1/2, and when x is negative 1, y is 2. So it's going to decrease. Similar kind of look, but now decreasing. This is called exponential decay. So when the base is greater than 1, we have exponential growth, and when the base is less than 1, still being positive, okay, not negative, then we have exponential decay. It decreases, right? Just a little background. Both of them, though, have a horizontal asymptote on the x-axis, unless I do vertical shifts. I mean, I'm not talking about transformations to this. I'm not talking about vertical shifts, horizontal shifts, reflections. I'm just talking about a basic function. All the other types of situations, you can graph on a graphing calculator, but just recognize, these special basic cases just to know what they look like. Now, the reason that they don't go past the x-axis, there are no negative y outcomes, is because I can't take a positive number and raise it to anything to create a negative outcome. Even if the exponent is negative, it just creates fractions, right? Y equals 2 to the x. If x were like negative 3, right? Then y would be 2 to the negative 3, and a negative exponent just tells me to flip it, and therefore this is equal to 1/8. So even if the exponent is negative, I'm not going to get any negative outcomes for y unless, of course, there's a reflection or a shift or anything like that. But this is just a number to the x power, okay? So that's why the range doesn't go below the x-axis. Also, there's nothing that I can raise, for example, 2. There's nothing I could raise this to create 0. 0 is not an option for an outcome for a basic function, right? I'm not talking about vertical shifts or horizontal shifts. I'm talking about basic cases, just a number to an exponent. Because even if x were 0, y is 2 to the 0. Anything to the 0 power is 1. So there's nothing that I could raise to to give me 0 or to give me negative. That's why the graph looks like this. It's always above the x-axis, not touching the x-axis. So horizontal asymptote at the x-axis. Now, of course, I could reflect it, shift it up, shift it down, shift it left, shift it right, and that's going to affect the range. And it'll affect the range, but I'm just talking about its basic form. Now, there's two special bases that we talk about, base 10 and base E. Base 10, you talk about powers of 10, 10 to the x. This is, very common. 10 squared, 10 to the third, 10 to the fourth, very typical base. Base E could be new for you, might not be, I don't know. But E is a special number, just like pi is a special number for you. Pi is a special number when you deal with circles. E is a special number when you deal with exponential functions and logarithmic functions. Oops. E is a special number, and E is approximately 2.718, blah, blah, blah. It's an irrational number that continues forever, but approximately 2.718, and then it keeps going from there. Just like pi is approximately 3.14, and that's an irrational number. But E is used for exponential cases, and pi is used when you deal with circles and things like that. So E in this case is not a variable, it's a number. So E to the x would be an exponential function with base E. So I would, operate it the same way. 2.718. So if I want to do, let's say I want to determine the point when x is 2, what is y? Y is e squared. This is a number. I can use my calculator, e to the second power, to approximate this as 7.389, blah, blah, blah. Okay? So this is the exact representation of y in numerical form. And this is an approximation. Okay? E squared, if we want exact form, 7.389 approximately if we want approximate form. I'm going to put this in here just in case you forgot these. Properties of exponential cases. You need to know these if you don't. I'm just going to say properties of exponentials. These are properties of exponents. Just in case, if you have a product of two exponential terms or whatever with the same base, you add the exponents, you have to know these. If you're dividing, hopefully this is a quick review, you're subtracting, anything to the 0 power is 1, anything to a negative exponent, you flip it and you make the exponent positive. If you have a product raised to an exponent, then you could distribute that exponent. Or if you have a quotient raised to a single exponent, you could distribute that exponent. That's a B. These are the only kind of situations where you distribute an exponent. You never distribute an exponent if you have addition or subtraction in the middle. Only if multiplication or division do you distribute an exponent. If you have a fraction to a negative exponent, you could flip the fraction and make the exponent positive and then flip it, and then distribute. Okay? That's an M in case you can't tell. What else? Quick little review. You need to know all these. I think that's all of my. So any base here, if this was base e to the 0 is also 1. I think these are all of them, if I remember off the top of my head. So you need to know these also, all these properties of exponential functions, or exponents, because we use these when we talk about exponential functions.